Stoichiometry. This stoichiometry is a very important topic in your future examinations, particularly if you are opted for IIT or medical stream. In both the cases, this stoichiometry is important. Nearly 25% of questions in chemistry examinations, in the competitive examinations, directly or indirectly, they are related with this topic. This is very easy topic if you understand it properly and carefully. You have to follow from the beginning, then it is very easy for you. This stoichiometry consists of so many subtopics, namely mole concept, empirical formula and molecular formula, redox reactions, and stoichiometric calculations. Now, in present class, I am explaining you how to calculate, how to do the stoichiometric calculations. Stoichiometric calculations means the calculations which are made on the basis of a balanced chemical equation is said to be stoichiometric calculations. What is a balanced chemical equation? We have already discussed in the law of conservation of mass. According to law of conservation of mass, in a chemical reaction, the mass is neither be created nor destroyed. In any chemical reaction, the mass is neither be created nor destroyed. It means the total mass of the reactants is always equal to the total mass of the products. Now, in the chemical reactions or the chemical equations, we can compare these masses with respect to their molecular weights. For example, now I am taking a simple equation. Carbon, when burned in presence of oxygen, it will give us carbon dioxide. Carbon, when burned in presence of oxygen, it will give us carbon dioxide. Now, if you want to verify whether the reaction is suitable for the stoichiometric calculations or not, we can depend upon their molecular weights or atomic weights in case of atoms. Now, here carbon, one atom of carbon, according to this equation, one atom of carbon is reacting with one oxygen molecule to give one CO2 molecule. Now, first of all, we have to verify whether it is according to law of conservation of mass or not. Now, one atom of carbon, its atomic weight is 12. And oxygen, the two oxygen atoms are there. So, in O2, the molecular weight is 2 into 16, that is 32. Now, in CO2, you have one carbon atom and two oxygen atoms. So, carbon atom is 12 and oxygen, two oxygens, 2 into 16, 32. So, the total is equal to 44. So, these are the atomic weights and molecular weights respectively for carbon, oxygen and carbon dioxide. Now, here carbon and oxygen, these are the two reactants. Carbon dioxide is a product. Now, if you add these two, 12 plus 32, you will get 44. So, the total mass of reactants is 44 units and a total mass of products is also 44 units. That means it is according to law of conservation of mass. That means 44 grams of reactants are producing 44 grams of products, which indicates that no mass is destroyed or no mass is created. So, this reaction is suitable for stoichiometric calculations because it follows law of conservation of mass. So, those equations which are according to law of conservation of mass are said to be balanced chemical equations. A balanced chemical equation is useful for stoichiometric calculations. So here, by simple way, to check like this is very difficult task for us. So the simple way to verify whether the reaction is balanced or unbalanced is how many carbon atoms are at reactant side and how many carbon atoms are at product side. So one carbon atom is at reactant side. Now how many carbon atoms? There, one carbon. So carbons were balanced. Now two oxygen atoms are there at reactant side. Only two oxygen atoms are there in the product side. So they are also balanced. Now the reaction is said to be balanced. So here in the balanced chemical equation, now 12 units of carbon is reacting with 32 units of oxygen to give 44 units of carbon dioxide. Whatever the proportions that you have taken, they react with each other in this particular ratio only. This ratio will not change. If you take the substances in grams, they react according to this ratio in grams only. That means 12 grams of carbon will react with 32 grams of oxygen to give 44 grams of carbon dioxide. If you take in kilograms, 12 kilograms of carbon is reacting with 12 kilograms of carbon is reacting with 32 kilograms of oxygen to give 44 kilograms of carbon dioxide. Similarly, if you take 12 tons of carbon, this 12 tons of carbon requires 32 tons of oxygen to produce 44. With respect to this ratio only, they will react with each other. Now you may have problems like this. What is the amount of CO2 formed in the complete combustion of six grams of carbon. 6 grams of carbon. So you may get the problems like this. In this type of problems, what the thing that you have to do? First, you have to write down the equation for the required problem. So what is the problem? Burning of carbon in presence of oxygen to give carbon dioxide. So carbon C, oxygen O2 gives CO2. That is the required equation. C plus O2 gives CO2. Then in the second step, what you have to do? You should verify whether the written reaction is balanced or not. So 1C, 2O, 2O. So it was balanced. Now after balance in the chemical equation, the next step what you have to do, you should write the units under them. How many units of carbon is reacting with how many units of oxygen to produce how many units of CO2. That will be based on their atomic weights. Carbon atomic weight is 12. Oxygen molecular weight, 2 atoms are there, so 2 into 16, 32 to give one CO2 molecule, where they are 12 plus 32, 44 is the molecular weight of CO2. So 12 grams of carbon is reacting with 32 grams of oxygen to give 44 grams of carbon dioxide. That will be the required reaction. Now, what are the weights that were comparing? They are comparing with the weight of carbon dioxide formed from given weight of carbon. So, what is the relation? Just put down the relation. So, according to this relation, 12 grams of carbon can form 44 grams of CO2. That is the required relation. Now what they are asking? They are asking the mass of CO2 formed when 6 grams of carbon was completely burned. So from 12 grams, 44 grams of carbon dioxide is formed. Now for 6 grams of carbon, can form how many grams of CO2? So it was directly proportional. So 6 by 12 into 44. 2 times. This 2 here 22 times. So in the combustion of 6 grams of carbon, 22 grams of CO2 is formed. So these are the stages that were involved in the preparation of, in doing these such type of problems. Calculate the weight of MgO formed in the combustion of 8 grams of Mg. 8 grams of Mg. Now the atomic weights, Mg atomic weight is 24 and oxygen atomic weight is 16. Because you should learn or you should remember the molecular weights and atomic weights of important compounds. Because for a new elements or the new compounds, they will give you the atomic weights or the molecular weights. But those atoms which are familiar in our regular lessons, for such elements, they won't give us the atomic numbers. So here, first step that you have to do while doing this problem, what is the reaction of magnesium when it was burned? Magnesium, when burned in presence of oxygen, it will give us magnesium oxide. This equation, this is the required equation. Now this is the first step that what you have to do. This after reading the problem, first you should know what is the reaction involved. Magnesium was burned. Magnesium symbol is Mg. In presence of oxygen, oxygen symbol is O2. So Mg plus O2, and it is forming magnesium carbonate. If it is a new reaction, they will give you the equation also. But for a familiar reaction, I am telling you, they won't give you reaction. You should be in a position to write the equation. Or by practice, you will know how to write this equation. So Mg plus O2 gives MgO. The first step was finished. Now you have to verify whether it is according to law of conservation of mass or not, or if it is a balanced equation or not. So checking how many magnesiums are there in the reactant side and how many magnesiums are there in the product side. How many oxygens are there in the reactant side and how many oxygens are there in the product side. Now, one magnesium was present in reactant side. In product side also you have one magnesium. But in reactant side you have 2 oxygens, whereas only 1 oxygen is present in product side. So oxygens are not balanced. So you have to balance oxygen. So while balancing, you should not change the composition of the compound. So simply for balancing, you should not put 2 under O, because if it becomes MgO2, that compound is not at all there. So to balance oxygens, the way is to have to change the coefficient before the molecule. That means to increase the number of oxygen atoms, you should put 2 MgO. You should not write MgO2, because MgO2 is not exist. 2 MgO is there. Now whenever you put 2 here, automatically magnesiums are unbalanced. Make magnesium balanced, you should have write like this. So 2 Mg plus O2 gives 2 MgO. Now 2 Mgs are in the reactant side, 2 Mgs are in the product side. 2 oxygens are in the reactant side, 2 oxygens are in the product side. Now apply their atomic weights. A magnesium atomic weight is 24. So 2 into 24 grams of magnesium is reacting with 32 grams of oxygen to give 2 into 24 plus 16. 24 plus 16 means 2 into 40, that is 80 grams of Mg. That means here 48 magnesium is reacting with 32 grams of oxygen to give 80 grams of MgO. 48 plus 32, 80, 80. It was balanced. So this reaction is according to stoichiometric calculations. Now from this you can write down. Now what is the relation that they are asking? Calculate the weight of MgO from 8 grams of Mg. So they are comparing the weight of Mg and MgO. So a weight of Mg, 48 grams of Mg is forming 80 grams of MgO. So write down 48 grams of Mg forms 80 grams of MgO. Then what is they are asking? 8 grams of Mg can form how many grams of MgO? So lesser amount, so it will be 8 by 48 into 8. 8 by 48 into 80. 6 times. 80 by 60. So this 6 here, 1 6 is 6, 3 6 are 8 and 3 3. So 13.33 grams of MgO is formed in the complete combustion of 8 grams of Ng in presence of oxygen. Calculate the amount of SO2 formed in the complete combustion of sulfur in presence of O2. So here the required equation, sulfur when burned in presence of oxygen, it will give us sulfur dioxide. Sulfur on combustion in presence of oxygen will give us sulfur dioxide. So for this reaction the required equation is S plus O2 gives SO2. S plus O2 gives SO2. Sulfur atomic weight is 32. Oxygen molecular weight is also 32. Sulfur dioxide 32 plus 32, it is 64. So 32 grams of sulfur is combining with 32 grams of oxygen to give 64 grams of sulfur dioxide. That is the standard relation. Whatever the amounts that you are taking, they react with each other in that ratio only. And SO2 is formed in that ratio only. So now study the problem once again. Calculate the amount of SO2 formed in the complete combustion of 8 grams of sulfur. 8 grams of sulfur. So they are comparing with weight of sulfur with weight of CO2. So according to that, 32 grams of sulfur is producing 64 grams of SO2. So write down 32 grams of sulfur is produced sulfur can produce 32 grams of sulfur can produce 64 grams of SO2. 32 grams of sulfur can produce 64 grams of SO2. Now what is the problem? The SO2 produced from 8 grams of sulfur. SO2 produced from 8 grams of sulfur. If 32 grams of sulfur can produce 64 grams of SO2, 8 grams of sulfur can produce how many grams of SO2? So here 8 by 32 into 64, 4 times 16. So 16 grams of SO2 can be produced in the complete combustion of 8 grams of SO2. So in all these problems, the main thing what you have to do is, first you should identify the required equation. Combustion means burning in presence of oxygen is said to be combustion. So all elements will form respective oxides when they were subjected to combustion. Magnesium and combustion with oxygen gives magnesium oxide. Carbon plus oxygen gives carbon dioxide. Sulfur plus oxygen gives sulfur dioxide. Aluminium plus oxygen gives aluminium oxide. So any element, when it was burned in presence of oxygen or subjected to combustion in presence of oxygen, they will form the respective oxides. So you should know how to write the equation. After writing the equation, in the second step what you have to do, you should verify whether the equation is balanced or not. If the reaction is not balanced, you have to balance it. Then note down the number of units of each element or the compound involved in it, and you should compare all these things. Then you should do what is the relation that they are asking in the problem. With which element to which compound, or which compound to which compound, they are asking the relation. So mark those two. Then write down the step according to that stoichiometric equation. How many grams of that reactant is comparing with how many grams of product? Then what is the required calculation you should write, and then you have to calculate like this. Calculate the amount of CO2 formed in the complete decomposition of 50 grams of CaCO3. 50 grams of CaCO3. Calcium carbonate, any carbonate, when it was heated except sodium carbonate, it will gives us the respective oxides and carbon dioxide. So all these equations you should be familiar. Initially will give you the equations, but later in the later problems you should be in a position to write down the equation. That is the most crucial thing that you have to do. For a difficult equations, for difficult reactions, they will give you the equations, but simple reactions they won't give you equations. So by practice, while we are doing this, you should remember all these equations. So calcium carbonate, CaCO3, when it was heated, it decomposes to give calcium oxide and carbon dioxide. Calcium oxide and carbon dioxide. So here calcium atomic weight Ca is 40, Carbon is 12 and oxygen is 16. Up for 30 elements, you should learn the atomic weights. So calcium is 40. So 40 plus 12. 40 plus 12 plus 3 16s are 48. So the sum is equal to 100. Then here 40 plus 16, 56. And here 12 plus 32, 44. So 100 grams of CaCO3 can give 56 grams of CaO plus 44 grams of CO2. 56 plus 44 is 100. Here reactants is 100. So it is balanced. Or 1 calcium, 1 calcium. 1 carbon, 1 carbon. 3 oxygens, 1 plus 2, 3 oxygens. So equation is balanced. Now what is the relation that they are asking? Calculate the amount of CO2 from the decomposition of 50 grams of CaCO3. So they are asking CO2 and CaCO3. So from this equation, it is evident that 100 grams of calcium carbonate is producing 44 grams of CO2. Then write down the step. 100 grams of CaCO3 can produce 44 grams of CO2. 100 grams of CaCO3 can produce 44 grams of CO2. Then 50 grams of CaCO3 can produce how many grams of CO2? So 50 by 100 into 44, 2 times 22. So 22 grams of CO2 is producing. 50 grams CaCO3, you will get 22 grams of CO2. So again I will explain you. In such problems, you should read the problem carefully first. Then you should be in a position to write the equation, the required equation for the given problem. And then check that equation whether it is according to stoichiometric proportions or it is follows the law of conservation of mass. That we call it as a balancing of chemical equation. First you have to balance the reaction. After balancing, then you have to write down the units of, that is the molecular weights of each component present in that equation. Then which element is comparing it with which mass? Then you have to write down this expression, then calculation. These are the stepwise procedures that you have to follow to solve this type of problems. Another problem. Calculate the amount of O2 formed in the complete decomposition of 24.5 grams of KClO3. KClO3 gives KCl plus O2. Here atomic weights, K is equal to 39, Cl is equal to 35.5, oxygen 16. So this is the problem. Here they have already given the equation, because This is some new equation. So if it is a difficult equations, they will give you the equation, or else you should be in a position to write the equation on your own. Remember, only in rare cases they will give you the equations. In most of the cases, you have to write the equation on your own. When they given the equation, you should not feel it as a balanced equation. Again, you have to balance the equation. So now here the given equation KClO3 gives KCl plus O2. Now verify K, one K is there, one K is in the reactant side product. So K's were balanced. Cl, one Cl was in the reactant side and one Cl was in the product side. Then oxygens, here 3 oxygens are there, only 2 oxygens are there. So you have to balance oxygens because they are not balanced. Generally, if one side 3 and other side 2, they can be balanced by mutual multiplications. That is 3 with 2 and 2 with 3. They can easily be balanced. So here 3 oxygens are there and 2 oxygens are this side. So simply by writing 3 O2, it becomes 6 oxygens, and by writing 2 KClO3, 6 oxygens. But at the same time KCl was in balance, and it can be balanced by put KCl here. So the equation was balanced. So second step is also completed. Now you have to write down the molecular weights of each involved in the reaction. Potassium, you already know that potassium is 39. Cl 35.5. Then O 16, 3 O's are there, 48. So in adding all this, you will get 8 plus 5, 13, 13 plus 9. Sorry, 8, 13 plus 9, 22, 2, 6, 9, 12. 122.5 is the molecular weight of KClO3. But 2 into 122.5. 2 into 122.5. Then here 39, 35.5 KCl, 5, 14, 74.5. Two into 74.5, and here 3 into 32. That is 245. Then this is 149, and this is 96. So now what is they are asking? They are asking amount of O2 with amount of KClO3. So they are asking this relation. So according to this equation, 245 grams of KClO3 can give 96 grams of O2. So 245 grams of KClO3 can give 96 grams of O2. Now what they are asking? 24.5. KClO3 can give how many grams? 24.5 by 245 into 96. That is 9.6 grams. This will be the amount of O2 that can be formed in the complete decomposition of 24.5 grams of CO2.